Hello everyone. In previous lecture we had discussed about the permeability of soil and the different factors which affect the permeability of soil. And in this lecture we are going to study about a new concept. This is hydraulic gradient. So it is defined as the head loss per unit distance of flow. And this is we represent in mathematically like this: I equal to head loss h1 minus h2 by L, or if we consider h1 minus h2 as h, so I equal to h by L. You have to remember this formula, I equal to h by L, where h equal to h1 minus h2. Again we know, already discussed in previous lecture, that discharge Q equal to KIA. In place of I, we can replace it like K into H by L into A, where L equal to length of soil sample, A equal to cross sectional area of soil mass, H equal to H1 minus H2 equal to head loss or hydraulic head or pressure head. So let us solve a problem. Estimate the flow quantity which we have to find out in liter per second through the soil in the pipe as shown in figure. The pressure head in the two locations as shown in figure. The internal diameter of the pipe is 1 meter. Coefficient of permeability of soil is 1 into 10 to the power minus 5 meter per second. So this is our question. So let us solve it. First work is to find out the given data. So K equal to given here, coefficient of permeability, this is 1 into 10 to the power minus 5 meter per second. Internal diameter, this is small d equal to 1 meter. H1 equal to 2 meter. It is given H1 initial head, H1 equal to 2 meter, H2 equal to 1.5 meter. Length of soil is 10 meter. So here we have to find out flow quantity. So we know Q equal to KIA. Here K is given, A is given. A is area is not given, only diameter is given. So I is unknown, A is unknown. So let us find out one by one. After that we can calculate Q value. So I equal to, we know, H1 minus H2 by L. So 2 minus 1.5 by 10 equal to 0.05. It is unitless as meter, it is head also in meter, length also in meter. So obviously it is cancelled. Next is area. So diameter is given, so we can calculate by applying the formula A equal to pi by 4 into d square. So our answer is 0.78 meter square. So the flow quantity Q equal to K into I into A. So here we put all the values, 1 into 10 to the power minus 5 into 0.05 into 0.78 equal to 3.9 into 10 to the power minus 7. As it is given in the question that we have to convert this into liter per second, so that we convert it, and our answer is 3.9 into 10 to the power minus 4 liter per second. We divide it like this: 10 to the power minus 7, 10 to the power minus 3 into 10 to the power minus 4. We know 1 liter equal to 10 to the power minus 3 meter. So rest is how much? 3.9 into 10 to the power minus 4 liter per second. Next is seepage. Another term after permeability is seepage. The process, it is a process by which the water passes through the soil, is known as the seepage. Next is discharge velocity. These are the 2 mark question definitions. Like, it is defined as the rate of flow of water per unit total cross sectional area of the soil. So mathematically V equal to Q by A, or Q equal to V into A. Next, seepage velocity, Vs. So it is defined as the rate of discharge or flow of water per unit cross sectional area of void. So mathematically Vs equal to Q by AV, or implies Q equal to Vs into AV, area of void, Vs into area of void. So you have to remember this formula is also with their definitions. Next, let us find out a relation between seepage velocity Vs and discharge velocity V. So, the flow quantity Q equal to A into V we know. We give it equation 1. Again flow quantity Q equal to, we can write AV into Vs. We give it equation 2. So, now we compare equation 1 and 2. So, AV into Vs equal to A into V, or implies Vs equal to A by AV into V. This is equation 3. Again we know that porosity N equal to Vb by V. So, in place of Vb, volume of void, we can write area of void into length. We convert it area of void into length. So, AV into L by volume. Volume means area into length. So, length cancel, or implies N equal to, we find out AB by A. But here it is A by AV. So, this is the reciprocal of it. So, that we can write it Vs equal to 1 by N into V, or implies Vs equal to V by N. This is the relation between seepage velocity and velocity of flow or normal velocity. You have to remember this relationship, because in many problem you have to apply this formula to solve the problem. Next is determination of coefficient of permeability. It is very much important. The coefficient of permeability can be determined by using two laboratory methods. Also there is some field method or indirect methods, but in your syllabus only laboratory method is given. So that I will discuss only the two laboratory methods. The first one is constant head permeability test. The second is falling head permeability test. Both are laboratory tests, and it is done in the laboratory by direct measurement with the help of parameters, permeameters. It is an instrument by allowing the water to flow through the soil sample either under constant head or under variable head or falling head. And also permeability can also be determined directly by the field test, like pumping out test, pumping in test. And also there is some indirect methods like computation from grain size or specific surface. Number 2, horizontal capillarity test. Number 3, consolidation test data. So these are some indirect methods. By using these methods, we can also determine the coefficient of permeability. But now these are not necessary for you. Only these two laboratory methods are important for you. So let us discuss one by one. First is constant head permeability test. So the coefficient of permeability of a relatively more permeable soil can be determined in a laboratory by maintaining the head of the water constant, so that its name is constant head permeability test. Also the test is conducted in an instrument which is known as constant head permeameter. It consists of basically of a metallic mold, 100 mm internal diameter, 127.3 mm effective height, and 1000 ml capacity according to IS 2720 part XBII. And here the mold is provided with a detachable extension collar, 100 mm diameter, its diameter is 100 mm, height is 60 mm, required during compaction of soil. And the mold is provided with drainage base plate with races for porous stone, and the mold is fitted with a drainage cap having an inlet valve and an air release valve. And the drainage base and cap have fittings for clamping to the mold. And this is the total arrangement of constant head permeability test. Total arrangement, this is the sample. Here we have to put the sample. Here this is a porous dish. Above it we have to put the soil sample. Above it porous dish. Here it is a air valve. It is a tank, water supply, water supply here. This is the water table, overflow tank, constant head reservoir. This is, and this is the constant head chamber. This is the total height of water is h, and here the difference between the water level, this is h dash. This is the graduated jar to which the water can flow or discharge. So this is the total arrangement of this constant head permeability test. So the soil sample is placed inside the mold as shown in the figure between two porous discs, and the porous disc should be at least 10 times more permeable than the soil. So this porous disc should be 10 times more permeable as compared to this soil. The porous disc should be dried before those are placed in the mold, and the water tube should also be dried. The sample can be prepared by pouring the soil into it and tamping it to obtain the required density by using Proctor hammer. So we have to put the soil and also we have to compact the soil properly by using a Proctor hammer. And it is essential that the sample is fully saturated by allowing water to flow from base to the top after the soil has been placed in the mold. And this is done by attaching the constant head reservoir or tank to the drainage base. And the upward flow is maintained for sufficient time till on the air has been removed. After the soil sample has been saturated, the constant head reservoir is connected to the drainage tap. And after that, water is allowed to flow out from the drainage base for some time till a steady state is established. Sorry. For this lecture this much. In next lecture also we will discuss more about this constant head permeability.